If it is, you can see, you can see also, just try to see. There are 4 data points A, B, C, D. What is the value of A? 1, comma 1. Value of B? 1, comma 2. Value of C? 4, comma 4. Value of D? 5, comma 4. How many data points are given in the question? 4 data points. Given following 2 data points, after K means clustering with K equal to 2. So in the question, 4 data points are given. A, B, C, D. The value of K is 2. What does K represent? K represents number of clusters. That means these 4 data points should be divided into 2 clusters. AB in 1 cluster, CD in 1 cluster, AC, BD. Then how it should be divided? That we'll discuss now. So here, choose number of clusters. Clusters is given in the question K equal to 2. Now initialize centroid. What is a centroid? Every cluster has a center value which is called as centroid. K means use the concept of centroid. Centroid is the center value of a cluster. It is the center value of a cluster. So for understanding, we are representing C1 one cluster, C2 another cluster. Why we have taken 2 clusters here? Because in the question it is given, divide 4 data points into 2 clusters, C1 and C2. And centroid is the center point of each cluster. So in this question, we have to randomly select any 2 points as centroid. Randomly select any 2 points as centroids. Now, for this question, data point A, the value is 1, comma 1. Data point D, what is the value of D? 5, comma 4. So these 2 points are chosen as centroids for cluster 1 and cluster 2. I will repeat again. In the given question, we have to divide 4 points into 2 clusters. So we have just took 2 clusters. Okay. In these 2 clusters, we have to randomly choose. You can take A, B also. You can take C, D also. But here we are taking A as centroid for C1 and D as centroid for C2. So by default, A and D, A went to cluster 1 and D went to cluster 2. Now what we have to do? Now we have to choose whether B and C will move either to which cluster based on Euclidean distance. Is that clear? This will be clear if you write along with me. So here this is the first step. Choose number of clusters. Clusters is already given in the question. Then initialize the centroids. Initializing centroids can be chosen randomly. For this question, we are choosing centroid A. A is the centroid for cluster 1. D is the centroid for cluster 2. Now, our aim is to see whether B and C will go to cluster 1 or cluster 2. Based on what? Based on similarities. So here we use the formula of Euclidean distance. Euclidean distance is used to find the distance, and with the minimum distance the point will go to that cluster. So see here, first data point, second data point, third and fourth. Distance D to centroid 1. D to C1. See here, 1 under root of 1 minus 1 whole square plus 1 minus 1 whole square is 0. Now, why we have taken here C2? Fourth data point we have taken as centroid for second cluster. So distance to C2. 5 minus 1 whole square plus 4 minus 1 whole square, that is 16 plus 9, it is 25, value is 5. In the same way, distance from B to centroid, distance from C to centroid, distance from D to centroid. You want to note, you can note it. Distance from A to centroid is 0. 1 minus 1 whole square plus 2 minus 1 whole square is square root of 1 is 1. 4 minus 1 is under root of 9 plus 9 is 18, which is 4.24. And 5 minus 1, this is again 5. So distance from all the data points to centroid 1, distance from all the data points to centroid 2. Is that clear? What is the formula of Euclidean distance? Under root of x2 minus x1 whole square plus y2 minus y1 whole square. Either you can use Euclidean distance or you can go for Manhattan distance. So here we got values 0, 5, 1, 4.47. Out of these, the minimum distance is chosen. So already by default in the previous step, A1 cluster 1. See here. First data point move to which cluster? Centroid. What is the centroid of cluster 1? A. Then what is cluster 1? Cluster 2 we have D. Now based on the distance, see here, this is less 1 and this is okay, see here. This is 1 and this is 4.47. Which one is less here? 1. So this data point moves to which cluster? Cluster 1. Next one. 4.241, which is less here? 1. So data point moves to second cluster. In that way, the points will move to the clusters based on the Euclidean distance. Is that clear? Then here we have to see one more thing. When the data points are moved to the cluster, the centroid value will change. Whenever a new data point moves to that cluster, the centroid will change. So new centroid should be calculated. Step 1, find the number of clusters which is given in the question. Step 2, randomly choose any 2 points as centroids. Step 3, calculate the Euclidean distance. Then the minimum one should be given to the clusters. After this, whenever a new data points move to the cluster, the centroid will change. So here, new centroid is equal to, see here, new centroid is equal to previous centroid plus the data point, and again new centroid of cluster 2 equal to previous centroid plus data point. So these are the new centroid values. See here. Now the centroid is equal to previous centroid plus 1, previous centroid 1 plus 1 2, 1 plus 2 by 2, 4 plus 5 by 2, 4 plus 5 by 2. Whenever a data point moves to the cluster, the centroid value will be changed. So we have to calculate the centroid value again. After calculating the centroid value, the new centroids are 1, 1.5, 4.5, 4. So previously we had different centroid values, now we got these centroid values. So what we have to do? Again we have to find out the distance. So again we have to find out the distance to check whether the clusters will remain same or not. If the clusters will remain the same, those are the final clusters, and stop finding the distance. So in this problem by default, even if we change the centroids also, the clusters will be same. That means A comma B will move to C1 and C comma D will move to C2. So these are total out of 4 data points, 2 points AB belongs to cluster 1 and CD belongs to cluster 2. This is how we calculate K-means. Is that clear, students? Should I repeat once? Given question, 4 data points. We have to, K is the number of clusters. Okay, cluster means group. Then centroid is the center value of a cluster which is chosen randomly based on the Euclideans. Based on the Euclidean distance, every data point moves to that cluster. When it moves, the centroid value will change. So here in the final step, we got AB in one cluster and CD in one cluster. Hope you understood. Okay. So if you have any doubts, you can ask. The remaining session will be continued by Lavanya Madam. Hope you understood. With practice is a problem. But I think fast. I don't know. Thank you, sir. JPC బాగుంటది కానీ మళ్ళీ ఆల్సో ఛాన్స్ రావాలి కదా ఇలాంటి నాకు తెలుసుకోవాలి స్టూడెంట్స్ ఐ అండర్స్టాండ్. Did you understand? Good morning, all. Right. Now, this the session you have seen clustering. What is a clustering? One word answer. Similar data items we are placing in a one place. We are gathering in one area, that we just call it as a clustering. Yes. Now we are coming to the different types of clustering. What are the different types of clustering you have seen? Partitioning clustering. Another one is hierarchical clustering. Then density based clustering, grid based clustering, model based. So many types we have. But we are learning in this session partitioning clustering. Okay, already it is completed. Now we are going to the hierarchical clustering. Why we need all these things? One clustering we have learned. All together we are sitting here. Why we are going to the another one? Here the reason I will tell you. Then I go to my why this topic we have chosen. Please listen carefully, everyone. Partitioning clustering now you have seen now. In this partitioning clustering, you need to know before itself the K value. What is this K? K means number of clusters. That before itself you need to know partitioning clustering. In the partitioning clustering, you need to know before itself how many clusters we need to divide. Whenever we are coming to the hierarchical clustering, it is not needed. That is the main reason why we are going to this particular hierarchical clustering. So many advantages and disadvantages is there. In this, why we are going to mainly hierarchical clustering is in the partitioning clustering. Before itself, you need to specify how many clusters you need to divide. Whenever we are coming to the hierarchical clustering, it is not needed. We are not specifying before itself how many clusters we are dividing. The K number is not needed. Then how you need to cluster, madam? That we are running now in this hierarchical clustering process. Is this clear? Why we are learning this particular cluster? The one point is mainly in a hierarchical clustering there is no need of before itself K value to specify. K value is how many clusters, how many number of groups you need to divide, how many clusters you need to divide. It is not needed in this particular hierarchical clustering. Now we are going to the hierarchical clustering. What is the hierarchical clustering? See here, hierarchical clustering is also one of the unsupervised learning clustering. Okay, you are reading now? Right. It is also one of the unsupervised machine learning algorithm. Here, what we need to do is hierarchy. The name itself it is specifying hierarchy, one by one. It is showing in the tree-like structure. That is the main difference between K-means clustering or a partitioning clustering to hierarchical clustering. In the partitioning clustering, we are dividing into groups. That's it. But whenever we are coming to the hierarchical clustering,
need to divide the data, then it will group the data. So in today's session, we will see agglomerative clustering. Okay guys, with program, with how the output will give you, then how the process it will do. That process we will see in this particular session. Right guys? Now we will go to the hierarchy clustering. In this hierarchy clustering, mainly you can see the data in the form of tree-like structure. I said that the tree itself we just call it as a dendrogram. These words you need to remember. It is very important. Mainly hierarchical clustering is divided into two different types. One is a agglomerative clustering, another one is divisive clustering. In this agglomerative clustering, it will represent the final output, it will represent, or the cluster it will represent in the form of tree-like structure, that we just call it as a dendrogram. The dendrogram itself you will see here how it is. This we just call it as a dendrogram. Right guys? Are you visualize this? The dendrogram is in this form. We have this, we just call it as a dendrogram. Okay? Now we will go with the procedure how the hierarchical clustering we will do using the agglomerative. In this the main strengths and the weaknesses strengths, if you can do no assumption on the number of cluster strengths. What I said, K is not needed. That is only the main strength whenever we are going to this agglomerative clustering. So there is no need of how many clusters we need to divide. Next we are going for the hierarchical clustering, which corresponds to meaningful taxonomies. That means whenever we are dividing the data, previously we see the applications, it will divide how you need it. In that way, it will divide into the segmentation. This is the one of the example you can see. Then we are going to the hierarchical clustering, two different types. One is a agglomerative clustering, another one is divisive clustering. So whenever we are going to agglomerative clustering, starts with points as individual clusters. It starts with the individual clusters, then it will combine into a single cluster. Then it will combine into a single cluster. Whenever we are going to the divisive clusters, it starts with all includes one cluster, then it will divide into a individual clusters. Is this clear everyone? So these are the two different varieties. What is this? The first point is every point is an individual cluster. The best example, you are entering into the college, you are individual student. When you enter, after that you have your individual classroom, like your A section. How you can specify your comes under to the A section? Something like roll number 1 to 50. These people are come to one cluster. They have specified. You are coming into the college. You can specify your comes under to individual cluster. You are one only. When you are gathered in a one area or in your classroom, that is comes under to your one cluster. Whenever we are going to this particular agglomerative clustering or the divisive clustering, how the process we will do, that we need to know. How to do this particular agglomerative clustering or a divisive clustering. Before going to the divisive clustering, we can see the agglomerative clustering. Whatever clustering types we are seeing, that means we are dividing into a similar groups, or we are identifying this group related to, or this point related to this particular group. We use the distance formula what you have seen previously. Those two distance formulas only we can use. What are those two distance formulas? Euclidean distance or Manhattan distance. These are only the distances. For these points, this point is related to which group? How you can identify? Using the Euclidean distance or the Manhattan distance. So in this particular example, we are using the Euclidean distance. Using the Euclidean distance only, you can identify which group it is related to. Whenever we are going to this particular hierarchical clustering, here new words we need to know. First, you can take as a inputs all the clusters. For suppose here we have P1, P2, P3, P4. Something 4 different points we have taken. Now these 4 different points combined That is only our main motive in the hierarchical clustering. In the hierarchical clustering, what we are doing? All the clusters it is treated as an individual cluster. Then we need to combine and it will give a single cluster. Yes. For that, what you need to do here is starts with the all individual as a one cluster. Individuals. One by one is a one cluster that you can treat. Then next one is what you need to do. Find out the distance between all the items. Find out the distance between all the items. Then you can find out which one having the minimum distance. That you can see with the example here. See here everyone, in this particular example, this is your problem. See here, first what you need to do is, initially all are treated as an individual clusters. With the example I will explain this, please see everyone. Initially, you can treat it as every point is an individual cluster. Note it down. Then, after that, what you need to do is, you need to create a matrix. This what we just call it as a distance matrix, or you can call it is a matrix in this form. That is visualized in this form. What you need to take here is all your cluster points. You need to find out the distance between each and every cluster. Always the diagonal values are 0 only. Why? Because the distance between all those data points we will get 0 only. Yes or no? Always the distance between the same data point is 0 only. For that reason, the diagonal values we are getting is 0 only. Then after that, what you need to do is, here there is no specification of which cluster it is related to. There is no centroids and all. You need to find out distance between all the values with the same. Then you can create one distance matrix. Please do everyone with this. Do it. I have not completed here. So once you need to find out the distance between all the values. Here question I need to specify single linkage. In this agglomerative clustering, we have 4 different types. What are those? Single linkage, complete linkage, average linkage, and one more is words. One more is words. That is also one of the linkage variety. So how you can do all these 4 is, first one is single linkage. Single linkage means we are finding out distance between all the items now. At this time, how to combine all these items? That is specified using this single linkage or a complete linkage, or next one, maximum or a min linkage. That all we can specify using this matrix only. You can specify with a single linkage. If it is a single linkage, what you need to do here is, whenever you have seen this particular matrix, in this particular matrix, what is the minimum value? Which one having the minimum value? These values. 1 is the minimum value. With this 1, what all the values it is combined. You need to start combining those 2 values. So what all the values it is here? 142 with 40. 42 with 43 only. Yes or no? Now what you need to do here is, what we are doing here? Hierarchical clustering, what we are doing? We are combining into a single value. We are combining all together into a single cluster. These all are individual clusters. These all are individual clusters. At last, all together you can take it as a one cluster. How you can cluster it? For that also you need to follow some procedure. You can't do as you wish. For that, what you have done is here, we need to find out the first distance matrix. When it is a single linkage, you can go with a minimum value in these two. Minimum value of these two is, which one is the minimum value? 40 to 43. 40 to, here we need to find out one is a minimum value. This is clear. Then whenever I am combining, which value I need to place? 40 to 43. These two you need to combine. You can categorize as a one cluster. So using compute pairwise distances, 18 to 22 is 4, 22 25 is 3, 25 to 27 is 2, 40 to 43 is 1. Now we are going to the single linkage. What is the minimum value? Here 1 only the minimum value. So you need to reduce minimum distance is 1 between 40 to 43. These two we have combined. Now this is the one cluster. Now how many clusters here we have? Total number of values, how many we have taken? 6 values. 6 different clusters is there. Now we are reducing it into 5 different clusters. Are you clear everyone? Like this you need to reduce and you will get a single cluster. That is only your hierarchy clustering. Now we are going to the next point. Same you need to repeat till you will get a single cluster. Then you need to find out the next step is distance between these 18 to again all the values. Then again you need to find out 22 to all the values, 25 to all the values, 27 to all the values. Distance between all the items you need to find out. Now you need to find out distance between all those values. Then distance between 25 and 27 you will get a 2. This if you will do the calculation then only you can know. Then you will do with this after combining 25 and 27 you will get the next cluster is combined with 22, 25, 27 is treated as another cluster based on their distance value. Makes 22, 25, 27 because here this distance between all the items, this is only the minimum value. Then you will combine these values, then you will get a, this is another cluster. First cluster we have taken is 42, 43. Then next cluster is 25, 27. We are not specified here. Then next 25, 27 with 22 also is a one more cluster. Then we are going to the next cluster is with 18, 22, 25, 27. And 42, 43. Then at last you need to combine, then you will get a, your final cluster is 18, 22, 25, 27, 42. So all the values you have combined, you will get a single cluster. First step is you have seen with all our individual clusters. Now we are going to see at last final, you will get all are combined into a one cluster. This what? It is a agglomerative clustering. The agglomerative clustering. First you can treat it as a all are a individual clusters. Then you need to combine. You will get at last only one cluster. How you can represent this is using with a dendrogram. That also I will show you. This is your final output. How you will get. First you need to combine 42 and 43. Then you need to combine 25 and 27. How you need to draw that? Those. Then 22 with 25 and 27. Then 18 with 22, 25, 27. Then all together you will combine with the 42, 43 with, this is a second cluster 18, 22, 25. Then you will get, this is your realized structure. Is it clear everyone?
Yes.
This is about agglomerative clustering. Now we will see this as a program. Whatever the process we have done, this we can see in your Python, right? Those things also have been in this. Right, see guys, here whenever we are going to do this Python programming, very important point we need to know about is how to add the data points to a data set. Everyone, I think so you know about those things. Mainly two different libraries we need to know. One is a NumPy, another one is pandas. Using the NumPy, numerical operations you can do that you have learned. Then we are going with the pandas. That is also for data set connectivity. We know definitely the pandas. Then after that, what is the outputs we are getting here? Which type of output for this particular hierarchical clustering? We need it is in the form of tree-like structures. Something like dendrograms or a circular formats. These are all the different types of structures we have. For those we have dendrogram is one of the structure or one of the package we have in this Python. At the same time, whenever we are discussing with the visualization techniques, definitely we will go with matplotlib. Everyone you know about this. Whenever we are discussing with the visualization, whatever the structures you needed, that all in the matplotlib and pyplot. In this particular library we have as well as scipy. So these are the all the predefined packages what we have that we need to add first. After that, here we need to add which technique we are using. Agglomerative technique only we are using. That is also we are importing here. After that, define first the data points. What we need to do here? We need to define what all the data points we have. So first, you need to define the data points. If it is 2D, you can use x1 minus x2 whole square plus y1 minus y2 whole square. If it is a single dimensional, directly you can differentiate by like a x1 minus x2 whole square. Next, x1 minus y1 whole square, x2 minus y2 whole square, x3 minus y3 whole square. Like that only you can do your single dimensional matrix form. Right? Here I have taken it is a single dimensional only. What are the values? Now we have seen as a problem that values only I have taken here 18, 22, 25, 27, 42, 43. Then what we have done? Perform directly the hierarchical clustering. Then I am using the method is single linkage. Different types we have now. Single linkage it will link with or it will minimize with minimum value. When it is a complete linkage, it will minimize with maximum value. When it is an average linkage, it will minimize with average value. Is it clear, guys? So here we are using single linkage only the method what we have taken, and linkage of data points method is single linkage. What is the formula we are using? Is it Euclidean or a Manhattan? We have specified here it is a Euclidean distance. Now we are giving here input we have given. What is the output you need it? We need the output in the size of 3 by 3 only. I have taken here it is in a 3 by 3. If you can give a 10 by 5, then it will give the picture representation in a big size. That's it. For that only we are using the fixed size, figure size. Then title of this particular plot is hierarchical clustering dendrogram for a data points. Then x label and y label I have entered here. See, with the output we can compare, then we can understand those all the points. Hierarchical clustering dendrogram for data points. Those all plotting how it will represent those all the values only I have given. It is just a 3 by 3 matrix, data points and the distance. This is x value and the y value. Then this is the main function we are calling here, that is dendrogram. In this particular dendrogram, we need labels, data points dot plateau. Now you need to call which method we are using for this dendrogram designing. Which method we are using? In hierarchical clustering, which method we have learned here? Agglomerative clustering. So whenever I am going to call method hierarchical clustering, HC is simply hierarchical clustering is equal to agglomerative clustering of n underscore clusters efficiently. If we are using here Euclidean as well as single linkage. Otherwise, you can write here directly Z value also. This Z value only here we have taken first. Please listen everyone. Here we have taken Z is, this is the function what we are calling, that value with all the labels we have taken, then plot it. Whenever we are going to call the agglomerative clustering also, you need to give which method we are using. Is it a Euclidean distance or not? Another one is whenever we are going to, is it it's a single linkage or complete linkage, which method we are using, that also we need to specify. Then cluster labels are predicted data only. This we have given as a your data points. Whatever the data points we have taken, that only we are specifying here. These are the data points we have taken. Those we need to place. Now we need to call this function cluster labels is equal to LC dot predict data points. Then you need to print n clusters using single linkage cluster labels. Simply cluster labels you need to print. Right guys? Then you will get finally your dendrogram. There we are calling the dendrogram as our method. In this particular dendrogram we have given these all the data points with the calling of agglomerative clustering. Then it will display. This is your final one. So this is about your hierarchical clustering. I think so you can understand what we have discussed. Are you clear guys? Any more queries? Okay. Thank you. Right. What we have seen till now in a hierarchical clustering, agglomerative clustering we have seen. Then one more is there, that is divisive clustering. In this divisive clustering, what we will do? Please listen once guys. Whenever we are going to the hierarchical clustering, here the space and time complexity is big O of n square as well as big O of n cube. This is our time and space complexity of hierarchical clustering. These type of questions you will get in your NET and GATE exams. This is very important. This type of questions you will get in your NET and GATE exams. Right? This is about your hierarchical clustering, space complexity and time complexity. Then we are going to divisive hierarchical clustering. In this divisive hierarchical clustering, what we will do? What we will do in this divisive hierarchical clustering? Whenever we are going to see the divisive hierarchical clustering, previously what we have done? Agglomerative clustering. In this agglomerative clustering, all the data points treated as a individual clusters. Then we have combined into a single cluster. Yes. Now, whenever we are going to this divisive clustering, I'll write here itself. So in the divisive clustering, what we will do is all the values it is treated as a all the values, what all the values we have is treated as a one cluster. Now what it will do, how it will divide. Whenever we are going to this particular division cluster, all the values it is treated as a one cluster. After that, it will use MST. Do you remember in your, I think so, in the MST. What is MST? Minimal spanning tree. Using the minimal spanning tree, what it will do is, whenever you have designed your matrix based on the minimal spanning tree, it will divide into all the values for all the categories, points, whatever you have taken, for all the values, which one it is related to. First, it needs to find out point 1, P1, it is related to which value. Then P2, then P3. Like that, if you have taken all the data points, distance between all, find out spanning tree. We need to design your tree structure based on minimum spanning tree. You need to design your tree structure. Then you need to start dividing into a individual clusters. Right. Now we will take the values of. Say the points are like simply 18, 22. Previously what we have taken the same only. I use here 25, 27, 42, 43. Yes. Now you can design your table matrix minimum spanning tree. So here 18, 22, 25, 27, 42, 43. For this, you need to find out your distance matrix. Yes, find out the distance matrix. We have seen here already previously. So 18 minus 18 is 0. 18 minus 22 is 18 minus 25. 18 minus 27. 18 minus 42. 18 minus 43. In the same manner, you need to find out. For all these, I need to give a naming P1, P2, P3, P4, P5, P6. 6 data points I have taken. For all these, I am giving the naming is P1, P2, P3, P4. Yes?
Make it close, man. The corner.
Madam, right side. Close.
If you can say fastly, then I give you the division algorithm. Yes, tell me guys.
9.
Then 22 minus 8. 4. 0. 0. 27 minus 22, 5. 27 minus 25, 2. 36. Yeah, everyone, you can know this how to do, right? After that, we are going to know about now divisive algorithm. Directly divisive algorithm I am doing here. So whenever we are going to this particular divisive algorithm, these are your data points if you have taken. Then you need to find out the adjacency matrix. Do you remember the adjacency matrix? This is only we just call it as adjacency matrix. Now you need to find out the edges and their cost. Edge and cost. I need to define now minimum spanning tree. For that minimum spanning tree, first you need to design this adjacency matrix. After the adjacency matrix, you need to go with the edge and cost, but with all the values, whatever the data points we have. What are the data points here we have? P1, P2, P3, P4. P1, P2. What is the cost? P1, P2, 4. Like this, you need to write P1, P3. P1, P3 is 7. P1, P4, 9. Like this again, you need to write edge and then cost. Are you clear? After defining the adjacency matrix, you need to write the edges and then cost. After that, you can take your 4 data points. What are those 4 data points? P1, P2, something I have taken like this, P3, P4. After that, whenever I need to combine P1 to P2, P1 to P3, P1 to P4, that means all the values you need to see which one having the minimum value. In all these things, which one having the minimum value? Which one having the minimum value? This one, 2 is the minimum value. That is P3 and P4. Yes? I need to combine first P3 and P4. What we are doing here is, first you need to create your minimum spanning tree, then only divisive algorithm will start. Here it is not yet started divisive algorithm. Divisive means divide the data. Whenever in a hierarchical clustering, merging the data. In agglomerative clustering, we are merging the data. In divisive clustering, we are dividing the data. So here, first you need to define your tree. After that, start dividing. Right? So P3, P4, you are having the cost is 2. Right? Then next, P1, P2, which one having the less value? For P1, P2. Or any other, here the next value is 3. The less value is 3. This is a combination of P3 and P2. Then only the one point it is pending, that is P1. See, P1 with P2, what is the cost? 4. P1 with P3, 7. P1 with P4, 9. In these 3, minimum value is 4 only. Now your minimum spanning tree is ready. Now your divisive algorithm will start. With this, what you have designed is, you have defined whatever the data points we have. With those data points, you have designed your adjacency matrix. With this adjacency matrix, you have designed your edges and their cost. You can divide your one table. Based on that particular table, you are designing your MST, minimum spanning tree. This is only minimum spanning tree. With this minimum spanning tree, your divisive algorithm will start. What you need to do in this divisive algorithm is, for these data points, which one having the minimum value, that you need to cut. That's it. What you have done, the minimum value is P3, P4. For this P3, P4, you need to cut it first. So how many clusters here we have? Cluster 1, first cluster is cluster 1, P1, P2, P3, P4. This is one cluster. First using the minimum spanning tree. Then C2, P1, P2, P3 is a one cluster, comma P4 is the another cluster. Do you understand what I am doing here? Previously, P1, P2, P3, P4, P5, P6 all are individual clusters. We have seen in the example 18, 22, 25 all are individual clusters. And you have combined as a single cluster. Here, what you need to do is all you have taken as a one cluster. Then you need to start dividing individually. So, first I have divided using as a minimum value. With the minimum value, you need to cut the edges. So here I cut with P3 and P4. So first P1, P2, P3 is one cluster. Then another one is P4 is another cluster. This is comes under to C3. Right. Then next one is C4. Whenever I am going to the C4, which one having the minimum value here? P2 and P3. So that you need to cut the edge. Now here C4 and C5. What are the C4 and C5 we have? C4 is P1, P2 is a one cluster. P1, P2 is a one cluster. Then C5 that is P3 single P3 is another cluster. Already C3 is having P4 only. Individual clusters is divided. Are you getting the point? C3 is a one cluster. C5 is one cluster. Now in the C4 you have P1 and P2. What is the minimum value? Only one value is that you need to cut. This edge also you need to cut. Then finally your clusters are C6. C6 it is P1. C7 P2. C3 P4 and C5 it is P3. All the clusters are combined, that is your C1. Now all the clusters are individual, these are your divisive ones. Divided into all the clusters into a individual clusters. This is only your divisive algorithm. Okay, so who don't know, maybe they can understand little bit, at least 5% or 10%. What it is. In an agglomerative clustering, what we have done is, these are the values we have. This we have combined into a single cluster. That is agglomerative cluster. In divisive clustering, we have taken the values are in a combined manner, that we are divided into a individual cluster. Is it clear, guys? What we have done in this hierarchical clustering. In the hierarchical clustering, we have two different types of clusterings. That is, one is a agglomerative clustering, another one is divisive clustering. In the agglomerative clustering, we are combining all the data into a single cluster. Whenever we are going to the divisive clustering, what we have, that combined data again divide into a individual clusters. Then we need to know one more point. Here also we have a drawback. What is that particular drawback is, data points are very huge, like a big data. The word you have heard so many times, big data. Big data means very huge data points we have at that time. It is difficult again. That means if you have a 5 data points, I will do this. 10 data points, I will do this. 100, okay. 10,000, okay. Whenever you are going to 1 lakh or 10 million or more, again, it is very big process. For that reason, we are going to the next variety or a next different type of clustering is density based clustering. With this, I just conclude. Right, guys? Is it clear?
Yes, ma'am.
Right. Thank you.
Okay, students,